The first Data Futurology event next year is going to be Ops World, data-centric operations for business value. We're going to be hosting the community in person at the Sofitel Wentworth in Sydney on March 14th and 15th. We're going to be discussing operationalizing securely for business value, impact, and scale. What are we operationalizing? Everything across the data analytics and AI space. We're bringing all the ops perspectives together into this one event. So it's going to be data ops, operationalizing data pipelines, analytics ops, operationalizing our analytics, MLOps, and AI ops, about operationalizing machine learning and artificial intelligence in our businesses. We're going to be discussing processes, frameworks, the observability, and the future of this space. Check out the website for more and hope to see you there.
I'd like to say a big thank you to our sponsors, Talent Insights. Talent Insights are Australia's leading specialist data recruitment business. With offices in Sydney, Melbourne, and Brisbane, they're experts at providing recruitment strategy and building data teams for clients across industries Australia-wide. They provide recruitment solutions for all roles across the data lifecycle, including data engineering, data science, advanced analytics, customer and marketing insights, business intelligence, data product managers, and data governance. They're skilled at finding the best permanent and contract hires for your business needs, as well as statement of work, project focus, data resources. At Talent Insights, relationships matter most. I can say from first-hand experience, Talent Insights are fantastic to work with. Whether you're a business leader within an HR network or a specialist data candidate, Talent Insights should be the first company you turn to for all your data recruitment needs. Find them at talentinsights.com.au. Hi, this is Felipe Flores and welcome to Data Futurology. Today we're going to be discussing all things in the future of data management. So we're going to be looking at how we can use Web3 technologies and blockchain in the data management space and what this can unlock for organizations. I am very, very excited to discuss this topic, and we couldn't find a better guest for this. We have Eliud Polanco. He is the president of Fluree, who is building data ecosystems with Web3 technologies. Eliud, thank you so much for being on the show. How are you doing today?
Excellent, Felipe. It's a pleasure to be here, and I'm doing very well.
Too kind. Thank you. So I might ask you to give us a very quick overview of your background, your amazing background, to kick things off, that you have such an extensive experience in data management. Could you give us a little bit of an overview, and then we jump into the issues that you've seen in the industry over your time? But first, let's start with your background, please.
Sure. So maybe about 20 years ago, I was primarily working in financial services and in banking and dealing with extremely difficult data challenges and large volumes of data. So I used to kind of work at a group, and I had a data innovation group at Citigroup. And then I was the global head of analytics at HSBC. And then I did work at Deutsche Bank and Scotiabank. And in most cases, it's just dealing with really large volumes of data, standing up high performance analytics teams and setting up data governance structure and quality control. And since I left working in banking, I was in consulting for a while and just helping organizations across many different industries kind of get their arms around data and try to think about how do you set up the data structures and the teams and the organization and the culture and the technology. And one thing that I learned is that as bad as I thought as I had it in financial services, it's even worse in many other sectors that are not spending as much or as mature. And so I'm really kind of interested in kind of sharing some of the observations about what I've seen, experienced firsthand, and see if we can kind of put our arms around how do we just deal with data better.
What are some of the pain points and challenges that you've seen?
Yeah, so I used to run a team of data scientists. And let's say that someone in the business said, hey, I need you to kind of, build a brand new model. And let's say build kind of a new, let's say, loan scoring model, right? Or credit decisioning model or cybersecurity model. It doesn't matter what the model type was. And let's say the business said, we've got 10 weeks to build this model and get it into production. I'd probably spend 8.5 weeks just trying to get my hands around the data and try to figure out what's the right data, and which one should I use and how to get my hands on it. And then I'd race the last week and a half to try to actually build and test the model and get something, viable, kind of ready for use. So every project was a heart attack. Right? Mm-hmm. And so we'd sit there and we'd go, there's got to be a better way to do this than people constantly fumbling with, okay, so what data sources do I use and where do I find the data and what data do I have? And so I realized that this is a kind of a universal problem. Most companies talk about how valuable data is. But in this case, the value of data, and what's kind of very interesting, the paradox is it's not because data is scarce, because we have too much of it, right? And so the big challenge that we've got is that we've got so many copies of data, and people, when they want to build reports, they take their versions of data and they might enrich it a little bit. And so you have so many different versions of slightly off data that nobody knows what to trust anymore. And I think that at its core is one of the big problems that we're seeing, right? Is that most companies are maybe using 10% of their data assets really effectively, right? In some cases, 10% is aspirational. Most business people don't trust their data. Companies are spending millions of dollars. It's not like they're not putting investment dollars against it. So they're investing in governance and catalogs. But there's something still kind of fundamentally, systemically wrong in that we're trying and we're putting in all this effort, but we're still not able to make really good traction on how do I just make my data available and ready and easy to use. And that kind of paradox has been the one that I've kind of been scratching my head for the last 10 years in particular, trying to think there's got to be a better way to do it.
Yeah, that is so true. That the access to the data is generally difficult, particularly in large organizations. And knowing where the data is, what the quality of the data is, what transformations have been done to the data and for what purpose is difficult. So then that all kind of amounts to a level of trust in the data is very often quite low. And as a result, when people interact with the data, they want to make their own version. They're sort of biased towards making their own copy, as you said, their own version of the data, and then move on from that point. It's something that I definitely see as a pain point. How do you think organizations can start to think about this particular challenge?
Yeah. So at its core, kind of like the proximate answer is stop copying data, right? So that's kind of like the easy answer, which is okay. Just the reason why we got into this mess is because we have so many copies of the data all over the place. Like I said, everybody builds their own data mart. Everybody has their own data warehouse. They create their own views, right? So that's kind of the easy answer, but that doesn't really solve the problem. I think if we go back to the root of why is it that we create so many copies to begin with? And you realize that, like I said, this is a systemic thing because it's not like one company is doing it wrong. Every company is doing it the same way. This is a very common problem in every industry that I've been in, that I've talked to chief data officers and chief analytic officers. There's something systemic that's going on. And if you take a step back, I think from our point of view and from what I've seen, a lot of it is, if you think about the business model for how data is created, most data is created in a kind of a business function-centric model, meaning the business function goes out and they purchase software and they define their data. And while it makes the business extremely flexible and allows them to kind of move at the speed of automation, it does create these data silos. And this is kind of like the unintended consequence of the IT revolution, of the mass productivity that we got from technology and computing. But the fact that the business functions can go out, buy their own applications. Now they can even buy them software as a service, so they don't even need IT anymore, right? So they go out and they buy applications, and then the applications create the data. But when they create the data, they optimize the data for that specific process or that function. And what happens is that data needs to be used by lots of functions, right? And so how do you have functions talk to each other with data? Well, they have to transmit it and send it. So what will happen is, you have to take the data and you'll either message it through something like Kafka or something like a service bus, or you'll transform the data to ETL. But that process of being able to have people communicate and collaborate with each other with data, necessarily, because of the way data is created, necessarily forces you to copy it. And so for us, kind of what we were thinking was, well, if it's not the function-centric model, is there a different way to create data so that you're not copying data and moving data to the functions, but you're really flipping the order and you say, we're going to put data in the middle and we're going to have the functions come to the data as opposed to the other way around. And so that idea, that concept is kind of what got us thinking about what a different architecture for data can look like.
Yes, that's exactly what's required. So we can start to tackle some of these problems, and so people can increase the trust into the data, so we can still enable the speed of business to solve the problems that they need to solve at the speed that they need to be able to do it, but do it in a way that then we're able to track the changes in the data as they happen, and that is available for people to both collaborate on and have a trust, a level of trust that that they can rely on the data that is there. So yeah, and it's interesting because there's such a big revolution in as you were saying, in things like low code, no code, in SaaS applications, and businesses able to turn these applications on quite quickly to get moving, and then the data teams and the analytics teams, obviously we don't want to be blockers, but we don't want to be left behind. We want to be in the mix there. And generally in organizations, there's more data work than the amount of people that are available. So that is also an additional constraint. How do you think we can balance the different trade-offs here, and what are good either methods of organizing our teams, or good systems or processes or different approaches that we can put in place to help ease this pain or find our way through it?
Yeah. So to your point, this is all about, we still want to maintain the level of business acceleration. So this is not about putting in blockers and saying, we're going to create an onerous set of standards before you can do anything with data, before you can be productive, because that'll never work, right? So there's an element of, let's say that we want to move from this kind of function-centric or application-centric of the world to like a more data-centric view. Mm-hmm. So part of this is going to be a cultural view, and part of the culture is saying no business function, no individual business function owns the data, right? The enterprise owns the data. You could be the steward of the data, but you don't own it. And there's a little bit of a cultural mind shift. And I know that when we were kind of thinking about this cultural mind shift, we're saying, okay, so what does a governance model look like when nobody owns it, but it's collectively owned by everybody? Like, how do you manage a public asset? And that's where we started looking at some of the interesting trends and some of the new models that we're seeing, which is all around, and really that kind of the whole Web3 ethos, which is around these more kind of decentralized models of managing data. And that started us to think about the fact that maybe there are new governance models and new technologies that will enable us to do more data-centric designs, or like we said, we're going to shift it from applications own the data to the data is decentrally owned, and that all the applications can contribute to it and they can all read from it. But we're going to change the pattern a little bit. And so part of from a technology standpoint, kind of the first major trend that we're seeing is we're seeing this kind of interesting kind of Web3 decentralized technology, zero trust architectures for data. What that means is that instead of thinking about data as being written into a database, think about data as being written into a protocol, and that anybody that subscribes to the protocol can instantaneously read any data as long as they're allowed to do it by policy. So imagine for a second that I could have two applications, each write their own data, but they're going to write it into a common protocol. And by writing into a protocol, everybody can see the data if they're allowed to see it. So everybody writes and everybody reads from the same data protocol. And a lot of that is like the way the distributed ledger technologies and kind of what a lot of the kind of the blockchain technologies do really well. So we think that's going to be one piece of the answer, is to start moving towards more of these zero trust architectures where you have a common data protocol with lots of readers and lots of writers, and everything is managed by policy. And what I mean by that is that anybody who writes a transaction into a database that commits a change has to be allowed to do it by policy. So each individual change has to be authenticated. We have to be authenticated. The change has to be immutable. And we need to say, okay, you're allowed to make the change and you've made this change and we see the lineage of what you did. And simultaneously, anybody who can read the data will have to get authenticated and read it, but it's instantaneous. So the second that I make a change, if you have the policy rights to it, you can see it. So we do see these architectures where lots of applications, it's kind of like every application writing into the same universal database. That's the kind of the thought process that we're thinking is one step of the puzzle. How do you move from application-centric data stores to more universal data stores that can be shared by the enterprise?
That's great. That's great. So with that universal data store and having it as a data-centric approach, then we have the different applications directly interacting with the protocol that holds the data, and so all the data will be stored there, and in a way that is that you can track changes, that it's immutable, and people in software systems will have access to read and write on the data according to their level of permissions. So that sounds like a really great way to tackle the data access issues that people have at the moment. What about when we think about the data definitions and the data structures, and having kind of the either agreements across the business or within business units around how to define when a customer becomes a customer, or when churn happens, and so I guess in a more general perspective, what about the data definitions at a division level or enterprise level? How could that work in this data-centric world?
Yeah. So one of the interesting things, and I don't know, Felipe, if you've kind of lived through this yourself, but what tends to happen is we live in a world where the applications write the data in their own schemas or in their own data models. And then like the separate data governance team has the official dictionary, but they put the dictionary in a catalog system, like a Calibra or a Lation or something like that, right? And then they keep these maps, right? Okay, so what you call this is what the enterprise definition is this, right? And so we kind of have these mappings in a catalog. And so I had the data sitting over here, but I had the semantics and what the data means sitting somewhere else. Mm-hmm. And so we said, okay, part two of the equation is how do we converge it so that the semantics of the data is co-resident with the data itself? In other words, you cannot pull the metadata away from the data. The meaning and the context of the data has got to be embedded in the data. So again, looking at what are some of the trends in kind of the Web3 space, one of the things that we're really excited about is there's this kind of emerging new standard for how a lot of web data is being generated, where they're putting the semantics directly on the data. And so if you're familiar with like JSON data, so like JavaScript object notation, so there's this kind of new standard called JSON linked data, or JSON LD. And the idea behind this is you're going to have your JSON data, and a lot of IoT devices and a lot of websites are now publish everything as JSONs. So let's say you have your JSON data, which contains the values, but using JSON linked data, you can actually now store the semantic relationships and save it as just information that's kind of embedded in the data. So what this means is that you can have a block of data, right? And let's kind of going back to this distributed ledger, this immutable copy. I can have a block of data. Let's say that this block of data has information about me, right? So it's got my name and it's got my address and some kind of verified immutable information about myself. I can embed inside each block the semantics using something like JSON-LD. I can embed the semantic definition of that data directly in the block so that anyone who reads from the block will be able to, if they understand the ontology, will be able to transcribe it and read it. And that's how a lot of, if you think about how Google works, right? One of the reasons why Google is able to do more intelligent searching when you kind of go out and say, find me all the websites that contain this information, is that more people are embedding semantics inside their web pages make it easier for SEO targeting and for like these bots that can go and scan the data. So think about doing that same concept of embedding the definitions and the logic directly inside the data. So it's much easier for anyone who's querying the distributed ledger or creating this universal data store to find the data. We call that self-describing data, meaning that you cannot separate the definition of the data outside of the data itself. And therefore, you put the data in the universal data store and anyone should be able to query it and find it and access it, as long as they're allowed to by policy.
Yeah, that's great. That's great. Tying the data together with the description and the definitions is fantastic, because then wherever they're accessed or used, the two sit together. And do the access control? Do you see the access controls sitting together in that way as well, or how do you see that side of the governance, so the access of the data?
Yeah. So that's the other kind of interesting innovation and the kind of really big revolution that we're seeing around these kind of new Web3 spaces is that, again, the access control used to be on the application layer, or in some cases, we put it in a separate entitlements policy engine. But now what we want to do is we want to do the same thing, right? We don't want to have the data here and the access logic over here. We need to embed the access logic directly into the data itself. And so thinking about how this is done in the Web3 space, so each block of data could have like a smart contract, which is basically a program or a policy that defines who can do what inside that block of data. And so if you think about like something like a non-fungible token, right? All it is the piece of data, like a graphic of like a bored ape or something. It's just a piece of data with a contract around it that defines that this exists in this instance and here's the owner of it. And if I sell it to someone, the knowledge of who I sold it to is embedded inside the contract. So imagine if every block of data had a contract around it that allowed you to define who can read it, who can see it, who can write it, but you can write into the smart contract using the semantics itself. So if we said only people who work in finance are allowed to see this block of data that contains salary information, that's the smart contract, right? You embed that directly in the block of the data, and then you describe it. So the data is described as having financial information, and we put the policy around it because only people in finance can see this. And so anybody can get access to the ledger. But when you query the ledger to get information out of it, if you're not in finance, you won't even know that block exists because it won't even appear to you. And that's kind of the idea, the theme of take the block, distribute it, zero trust, every read and every write has to be authenticated, and then embed the semantics and embed the access control directly in the block.
Yeah, that's excellent. That's excellent. And tell me, how is zero trust in this case different or similar to a principle of least privileges that some organizations might have, of kind of like denial of access by default, essentially, and then people have to sort of prove that or make a case for why they need the data, and then their privileges might be escalated in order to get access. So I'm just thinking about kind of like the different models. And in zero trust, how is it similar or different to some of the data access models that might be out there today?
Yeah, so I'll kind of describe, I think, two really interesting innovations around the zero trust model that I think will make this thing extremely interesting compared to kind of existing attribute-based access control. So the first nature of a lot of these like smart contracts for data is that the contracts themselves is data. And so there's a little bit of like a recursive nature to these smart contracts where when I describe the policy, for example, that said only people in finance are allowed to get access to blocks of data that contain employment, salary, or compensation information, the contract that defines that is a block of data, just like the piece of information that says Felipe is in finance is a block of data, just like the piece of information that says that my salary is X is a block of data. And so, in essence, the data requires analyzing other data in order to enforce the policy inside the data. So it's kind of this interesting idea where as data changes, the access and the policy logic is changing in real time. So that's kind of the important thing, which is if I was to think about how do I manage policies today, if I entitle a user or I de-entitle a user, I probably need to go in and something happened in an application, and then the application has to report it to some other entitlements management system or some other policy system. And then that policy system has to then update its logic so that it can enforce the access control. But here we're talking about data and policies changing in real time as the data is changing. So in this case, instead of having like your information in one system and then I have to report it to LDAP and then LDAP has to report it to another system and then that system reports it into the entitlements management system, if I have a block of data that says Felipe is no longer in finance, in real time, the second that you're no longer in finance and you try to access the data, Zero Trust will not permit you to see the data. Right? So that's going to be one thing, is just the ease with which you can manage changes to policy in real time, because as the data is changing, the enforcement is changing, and every single interaction is a new re-authentication and authorization. So that's kind of one interesting benefit that we see from Zero Trust. The second one is you think about who manages the policy, and that's the other innovation from a governance standpoint. Who sets the policy and who can control it? Before, if I wanted to change the policy, I'd have to go to the application owner. And when GDPR came out, for example, and we said, don't let anybody get access to European customer data. I remember when I worked in one of the big global banks, we had to go and we had to create a little project for every single application. And so I had 100 simultaneous teams trying to meet GDPR requirements. In this new model, where it's kind of this decentralized model, you can have basically the equivalent of a data governance council that oversees all the data policies, and they can directly write the policy. So when they write the policy, instead of today where the data governance team writes a policy and then they give it to IT and then IT farms it out to all the different technology projects or the teams, and then you create a different project for each individual enforcement of the policy, the policy can be acted on directly by the Data Governance Council as a decentralized unit that's managing and overseeing the data. So it just fundamentally, I think, can change how you even think about who executes the policy. And that we found that pretty interesting about the fact of saying, in this kind of decentralized world, we don't have to go to each individual app owner to go and change and set the policies one application at a time. If you have your definitions of your data, then you can just make the changes in the policy and then get it enforced in kind of near real time.
It's really great. It's really exciting and inspiring to hear the possibilities under this new paradigm. There's so many questions I want to ask you. Maybe first I'll ask you if you can share any examples or use cases or areas where you've tried this. Any examples that you can share, I think it would be really interesting as well.
So we're working on this kind of first of a kind innovation pilot right now. And this is something that really kind of describes the difference between this kind of universal data store concept compared to kind of like a classic data warehouse with attribute-based access control. So the use case here is around consent management. Okay. So we've got a specific industry, and there's some new regulations that are coming online that are saying, if you're going to use the customer's information for sales and service purposes, the customer must actively sign off, and the customer must explicitly define which lines of business you're allowed to share their data with. Now, imagine trying to build an application where you're going to show the user his data and then let the user define which lines of business they want to, which attributes about themselves do they want to share with which line of business. So without this kind of concept of this kind of decentralized framework, this would have been the most complex Rube Goldberg application to try to build a system that's going to show the user all their data and then allow them to figure out, like, how do we set something that allows the user to define in a parameterized way what they want to share and what they don't want to share. Now, in a zero trust model, in this kind of decentralized model, what we can do is we can push the definition of the policy to the edge, meaning we can set it up and say, if you own the block of data, so if this block of data is about Felipe, Felipe is allowed to define the access control policies for any block that he owns. And then we can farm this out and decentralize this to 1 million users, right? So you can have 1 million users and say, as long as you own your blocks, it's very easy for you to query and look at any blocks that contain data that have information about you. And as long as you're verified as a verified credential within this block, you can control the access control for that block. So I actually envisioned that, and I actually think that, kind of in talking with some of the regulators, we're gonna see this movement from these like passive control management schemes to something a little bit more active, right? We used to live in a world where, they make you like read this like 900-page privacy policy, and then you'd be like, fine, and just click yes, I approve. And then the companies would take it and they wouldn't even meet the terms of the policy themselves, right? And so you get into these questions of, well, if I'm not going to read it and you're not going to enforce it, what are we doing, right? And so much of like GDPR 1.0 was a little bit of a lot of just paperwork, right? Fine, I'll update the privacy policy, but it didn't really change any fundamental behaviors. And so we think that as you start thinking about these more active control models, we do think that we're going to see kind of a model in the future where they're going to say, I need you to verify that you've actually implemented your privacy policy and that you've actually given your customers the right to remember stuff about themselves or forget stuff about themselves. And the easiest way to verify it is to show them, look, here's Felipe, and Felipe set the policy, and I can immutably prove to you that Felipe set this policy. And Felipe set the policy saying this is the information about himself that he wants to share. So again, it's kind of an interesting use case for the types of things that we'll be able to do with kind of zero trust model for data and data collaboration, where in this model, we're talking about not just sharing data amongst ourselves as a company, but with the customers and giving them an active say on how they want to use their data and share it.
Exactly. Yes. And it's phenomenal to be able to do the not only the access controls, but do kind of overall all the governance down to that level of detail. If that's required, then that's totally available. And that makes total sense. And then with the same smart contracts and the same policies, you could obfuscate data. You could have it that, some people might not see the date of birth, but they see the age, or, this privacy preserving that can be put into the policies. Super, super exciting.
There's one additional interesting feature that I want to talk about, Felipe, which is one other kind of unique pattern about this kind of decentralized space or this decentralized world. There's this concept that's been in the computer science world for years called secure multi-party computation. Mm-hmm. And the idea was that you wanted to have kind of like an anonymous agent act on your behalf to query data that I'm not allowed to see. Yeah. For example, let's say that I want to ask a question that says, am I making more money than Felipe? Mm-hmm. I'm not allowed to know what Felipe's information is. I can't see it. But if I had this autonomous agent say, look, I'm entrusting you, you're this kind of ephemeral agent, you exist for the sole purpose of just looking at the data and returning back a yes or no answer, right? Mm-hmm. So we can have this autonomous agent do that. You can ask for certain questions and I will never see the data. And we can manage that by policy and it's immutable. We can see who's ever accessed the data. So you can have these basically these kind of mathematical functions or proofs that are actually doing the query on your behalf and they can send answers back. Why is that interesting? I remember kind of working with big global banks where we'd have a really hard time with global data sharing on things like anti-money laundering, right? So I really need to know, is this guy doing business with somebody in Singapore who's on this watch list or something? Mm-hmm. But I'm not allowed to see any information about Singapore citizens because I'm resident here in the US, for example.
Yeah.
So that's a use case where the amount of hoops that we had to jump to try to like take data from Singapore, obfuscate it, put it on the edge, move it to Malaysia, where Malaysia has a contract where we can share data with the US, right? The amount of hoops that we just to facilitate something as simple as, I don't want to know anything, I just need to know, is he doing business with this guy? It's a yes or no question. We can now start asking yes or no questions without ever physically, I will never see the data, me physically being in the US, I will never see the data. The data will sit in country. I won't break any kind of residency laws. The autonomous agent that fires up the query will fire up the query in a data center in that country. And then it's going to return back an answer, and then we can push the answer up, but the answer itself will have no PII because the answer is yes or no, just as an example, right? So there's a lot of kind of like really interesting ways that we think about why is it so difficult to share data? Partially, it's because legally it's really hard, right? There's a lot of global regulations that come in between, provenance issues and cross-border residency. And so again, the idea of kind of having data in blocks and having zero trust really just opens up the door for all kinds of new ways to communicate with each other.
I love it. That is so powerful. That's amazing. Yes, because like there's always the trade-offs and the difficulties in between privacy and sometimes legislative requirements, like in this anti-money laundering AML case. I love it. It's extremely powerful. The other one that I thought of as you were talking was data lifecycle. That's another area where there's more and more regulation on how long should organizations keep data for, in what state, what type of aggregations are allowed to be kept for long, for what time period, who can have access to it. And there is more and more regulation coming into the space, but also often the regulation kind of contradicts each other. And then one says you might need to keep it for 2 years, and the other one says 7 years, and then they have different reasons. But being able to put this as code and have it as a smart contract, then you're able to both decentralize but apply the data lifecycle to the individual blocks of code.
Imagine that because data is immutable, every block of data and every change of block of data will be timestamped, right? And we have this kind of universal concept of time. And if you study kind of these decentralized technologies, the concept of time is extremely critical because you cannot enforce the contract if we don't agree on what time it is, right? So that's why the folks in this kind of Web3 space have spent a lot of time trying to think through how do you define the standards of time such that we can all universally agree, right? And therefore, when we set contracts, we can set contracts with a proper definition, an agreed definition of time embedded in them. So we can say, right, as part of the contract, if you're in this jurisdiction and the contract is that within 7 years, the data has to perish, as far as anyone accessing the data from that country is concerned, this data doesn't exist. If you're in a country that says that you need to keep it for 14 years, then the data will be exposed to and it does exist, right? So what we do is we use these access control policies at the block level. They're really atomic, almost like at a cell level. You can have policies that come in and allow you to say, the data is in this distributed ledger. And the way to think about the distributed ledger is it's kind of like a hash kind of encrypted version of a pointer to the actual data itself, right? And so what we can do is we can say, look, anybody can get access to the hash if the hash is irrelevant. The policy allows you to actually go and point to and look at the actual underlying piece of information under the index. So that's kind of the idea, right? Everybody gets copies of the index, and then you query the index. And if the policy says that it doesn't exist, as far as you're concerned, it doesn't exist. Right? So that's just a new way to kind of manage data retention by access control, by policy. And the big tough question, the other one that we spend a lot of time thinking about is, okay, this is great, but I have 40 years, 50 years worth of data in databases and data marts and data warehouses and spreadsheets and CSVs. Everything we're talking about is nice, but how am I going to get all my data from the world that I have today to this nirvana in the future? That's kind of the last major trend that we've been seeing. Because we've been thinking about boy, wouldn't it be great if there was a way for us to like by magic take all of our data and put policy around it, put semantics, and have it in this kind of universal data store. But the reality is most companies, it has not been easy to actually manage everything to a common vocabulary. Right? So like in the banking space, risk management speaks one language, finance speaks a completely different language. You're looking at the same exact data, right? But you call it a liability, I call it a guarantor's counterparty. The same thing, right? The same block of data. And kind of until we solve that problem, it's going to be really difficult, right? To like bring the data in one universal location where you can write it and I can read it and we both agree on what we're talking about. So the last major trend that we're seeing, and a lot of this is kind of picking up from the generative AI space, it's semantics and like being able to use AI to just introspect data and classify it and identify what the semantics are such that you can have AI identify and discover these semantic relationships. Okay, I get it. You call it client, I call it customer. It's the same thing. The data is the same. Yeah. And using some of these, ontology languages that exist in the Web3 space, you can just create these semantic equivalences, right? So you say, look, what I call customer name is equivalent to what you call account name. Like Salesforce, you call it a contact. He calls it a individual account holder. And then we save these semantic relationships in the data itself. And what's great is that using semantic knowledge graphs, and this is where JSON linked data comes in again. If you query the data, you can query the data across many simultaneous vocabularies. So if I say select star, get me all customer accounts, and in the graph it says, by the way, what you call customer account is what he calls client account. I can return back client account data that was quote unquote saved as client accounts. I can return it in a query for customer accounts. Right? And that's the last mile, right? I got to figure out how do I get my legacy data into a format with semantics around it. And this is where we're now starting to see this kind of emerging AI to kind of go through and scan the data, discover these relationships, and then bind and link the data, so that we can actually have a pipeline process that can help convert legacy data to data that's ready to operate in this new world.
I love the integration of the semantic layer of ontologies. It just multiplies the power of the data exponentially and makes it much more searchable and accessible and usable across the enterprise with the different, as you said, the different terms for the same definition. So everyone can speak their own language.
I want to go back a little bit to kind of like the original sin for why is it so hard for companies to use data. The original sin was we copied. We copied and we copied and we copied. And why did we copy? Because I needed to ETL the data because I call it clients, I call it customers. Right? It's the same thing, but I got to do transformation. I got to do a map, but I got to join something. You normalize it. I didn't normalize it. So by being able to just say, store the data at its most atomic level, add the layer of semantics on top of it, right? Now we can have data scientists or bots query it, grab it, roll it up however you want to. When you roll it up, we have the lineage of what you did because it's all immutable transformations. But the important thing is stop copying the data, right? You can copy the ledger to your heart's content, but the data itself should be immutable and we should not copy data. And that's how we're going to ultimately get around to a place where we can actually trust the data, right? Because this block of data only exists in one place for this point in time, all agree. And if anybody used that block of data, we know exactly where it came from, we know who wrote it, we know who read it. So that's kind of our vision, right? No more ETL, or reduce ETL to the least amount of absolutely possible. But let's start using these kind of immutable ledgers as a way for us to manage data without physically copying data over and over and over.
Yeah, amazing. I love it. And for people that are looking to give it a go, dip their toe in the water, or trying to do a pilot, or do a trial, how can people get started down this journey?
Yeah, so we're actually right now working on a series of automation solutions that will allow you to just take raw data, apply your ontologies around it, or we can apply, universal ontologies like things like schema.org. But what we do is we'll create the data and convert it into this JSON LD and move it into these semantic blocks. And so in about the first week of March, around early March, we're actually going to be going beta with our service. So we'd love to, Felipe, just point people some information to our website. The service will be launching pretty soon, and we'd love to get people to just log in, experiment, give it a try.
Awesome. And we will include the links on the show notes as well, so people can check it out. And Eliud, this has been super interesting, mind-blowing, and has me so excited about the possibilities. That the future of data management is here, and that we can solve so many of the pain points that we have in data management in organizations, and for individual citizens, like our lives are going to improve as a result, and the way that we interact with organizations, and in the way that we own and manage our personal data that is stored across so many organizations, that can all change and improve dramatically with everything that you just shared with us. So I really want to thank you for your time, for your thinking, for putting this plan into action, and helping bring this new world, make it a reality for us. So thank you so much for everything you do.
I had a great time.
Thanks for watching this video all the way to the end. I hope that you got a lot out of this discussion. And if you're watching on YouTube, please like and subscribe to the channel, so more people can find out about the challenges that leaders have in the analytics and AI space. And that's what we're trying to share in Data Futurology. So please like and subscribe. And if you enjoyed today's episode, please tell your friends. Thank you so much.